Oh, damn it. I'll be right back. Hold on. I need to change my keyboard shortcut to start recording. Because I have Control-Shift-R, which also refreshes, which makes me leave the meeting. Okay. All right.
Oh dear. Yeah, there's a big long list of constants at the start,
Mm.
which is maybe a little intimidating. I don't know.
Did you manually enter them?
No, I sort of just quickly wrote Ruby things to make them. Well, except for binary, I did that one myself. So basically what you do is you define what digits or what characters you're going to use to represent digits in your base, whatever you're doing. So decimal, you define 0, 1, 2, 3, up to 9. But for hex, it's 0 all the way to F. And for Glenn's base 36, it's 0 all the way to Z.
Right.
36?
Yeah, so that's 35 characters, which makes it base 32.
I was 32. I was doing 32.
Oh, is it 32?
Yeah,
but
16 by 2.
60.
But I like 36 because then you can go 4 more.
Yeah.
And your base 4 isn't going to work.
Oh yeah, I changed that to 3 numbers to help break. Okay, anyway. So we work with strings just because that's how it kind of goes. To convert a decimal number into the given base, we start with an empty string, and then as long as the decimal number is greater than the base, and the base is just defined as the length of the glyphs we defined earlier. So in decimal there are 10 characters here, so it's going to be base equals 10. In base 36 there are 36 characters here, so it's going to be base equals 36. So while the decimal number is greater than the base, in this case 36, we'll eat the remainder of the division. So what we're doing is we're looking up in this glyph table, in this glyph array, the index given by running modular arithmetic. So we divide the decimal number by the base, and then we look up the corresponding character in the array, which will conveniently always be correct because the 0th character of base 36 is 0, the 9th character is 9, the 10th character is A, and so on and so forth. So we look that up and we just append it to the string, and then we mutate the decimal number so that we can keep performing the operation. So this will just this is divide equals. It's like plus equals but with division. So it's just modifies the decimal number so we can just keep going, and so that we don't have an infinite loop dividing the same number eternally. Then finally the last step is, since at this point we have a decimal number that is less than the base, we finally just look up that decimal number in our glyph thing, and then finally reverse it because we've been working backwards.
Oh, so close. So close.
So that's how it works forwards, and then backwards is the same dealio.
Right. Nice. That's an interesting solution. I like the way you used the arrays there, the arrays of string digits to solve that. That's really nice.
Yeah. So it could do Babylonian if you wanted.
Does anybody have questions about that solution?
How do you get the last one?
That's this one here. So once we have a decimal number that's smaller than the base, so once we've divided it a whole bunch of times and until it can't divide anymore, once the number is smaller than the base, by definition we can't divide anymore. So then we just look up that digit.
So you're setting the base by what glyphs is equal to, right?
Yeah, base is with the length up here.
You're doing like before you change glyphs to equal to base 4, and that's like, so you're defining it in your script.
Yeah. So that's
Gotcha.
the spot where you change what base you're working in. You could do like a command line out and enter in your characters or something. But
Yeah.
That was all that was.
Or you could like input what base they wanted.
yeah, yeah. That's how that works. And yeah, the other way around is just sort of the same thing. Well, just the same algorithm that we saw on the screen, but with all this nonsense.
Oh.
It's not made English yet. It's not readable, but it works.
Yeah.
So star is.
That's
Raising it to the
that's how you
power.
raise the power. I
okay,
thought it was
that's
this,
exponential.
but this is some other mathematical operation.
Yeah.
I don't actually know what that is.
Is it like
Factorial?
No, is it like it's like it gives you a smaller number, so it's like logarithmic or something, maybe. Yeah, we should look it up and see what it is, but yeah, it gives you a smaller number than
That's that.
yeah, cool.
Well done.
Does somebody else want to share their solution? Because I'm sure there are much different solutions to this. Anybody?
Would it be right to just present 2y?
No.
I can if you want to.
Yeah.
More like
Like, what can I change that to? Nothing.
well, this ain't too hard of it.
Okay.
Yeah. Just do it the other way now.
Sad. Between how many hours and that's between 5 minutes.
Okay. So this first one is from base 10 to another base. So the number that comes in is base 10.
Yes. Alright, so let me just reread my code that I wrote for launch. Alright, so I'm taking into this method the base that you're converting from base 10 to and a number. This will only work for anything under base 10 because I haven't got a set of characters like Matt or something like that. I would need to set, I probably could do the same thing, but this will only work for under base 10. So I'm setting a remainders array to take the remainders of the division that we're doing, like that division operation that we were shown by Jill earlier. And while the number is greater than the base, which means it can still be divided by the base, I'm pushing the modulus of the number to the base. So that's basically just, I'm just taking the remainder of the number divided by the base and pushing it into an array. And then I'm just saying the number is the number divided by the base, and because they're both integers, it's not going to produce a float, so I'm just going to get the floored number return.
Yeah.
And so once I've done that enough times and the number is no longer divisible neatly by the base with the remainder, I reverse that array. I push that number in first, that last remaining number, because that's obviously our last digit.
Yes.
And then I'm reversing that array, and then I'm making the converted value just that array joined to I because it's going to become a string.
There's a tiny problem with this.
Is that?
No, there isn't. Never mind. You're fine. You're fine. Never mind. It's good. No, it's good. Oh, what happened?
After you shut him down.
I know. It was so offended. So offended. No, it's totally fine.
That's some weird script injection. And then the other way around is pretty much if my
Yeah.
Just remember what Jack just did and just reverse it.
Yeah.
and so I wrote a second method
Yes.
which does the same. It takes a number and it takes the base. The first thing it does is that it makes an array of the number,
Mm.
and it's just checking to make sure that none of those numbers in that array is greater than the size of the base.
Mm.
So greater than or equal to. If
To the
it is,
base.
then that number can't be a valid number in that base. So say you gave 1, 5, 3, and you were trying to convert to base 4. That's
yeah.
never going to work because
Mm.
5 isn't a number. Sorry, 5 isn't a number in base 4.
That's
So
right.
it's just checking for that condition. And then
And I know you mentioned it to a bunch of it, but the reason that you do reverse after digits is because digits.
yeah, it just returns an array of the number that you give it, but with the digits in reverse. I don't know why. So you always have to reverse if you use the digits. It's like using .chars, but if you gave it ABC, it would give you CDA.
Yeah,
Go figure.
it's really strange.
Then I'm initializing the converted value because I just needed to. And then I basically do the same conversion that Matt did. I do an each with index, giving it the unit being each individual value in that array, and then taking the index as well, and then just adding it to a converted value accumulator.
Mm-hmm.
Same calculation.
Yeah,
Returning it. That's it.
cool. Any questions about that one? So there's a little bit you might have to whenever you have something that looks like this with this long computation that's happening over there. Nobody can. Not nobody. I won't say nobody. Very few people can look at that and be like, "Oh yeah, I know exactly what that does." You have to write out. What I would do is I would write out some examples. Hand simulate some examples with the numbers so that I can understand what exactly is happening in this unit times base to the power of number array dot length minus index plus 1. Right? Because
I basically looked at the algorithm that we worked on to do our conversions.
Yes.
And then just looked at each individual component of that and looked at
Yes.
how can I make that something that I can put or set as a variable, or how can I pull that information out
yeah.
from where I already have it.
Mm-hmm.
For example,
Yeah, so we have to figure out which power of the base we need to multiply by.
Yeah.
Yeah, and so you're using the index to work that out.
Yeah. So
Yeah.
I know that if I'm taking that bottom number there on the very bottom of my screen, 1323. I know that's a base 4 number and I want to convert it to decimal. I know that that's going to have 4 different calculations that we need to make. The calculations for the 4 to the power 3 place, 4 to the power 2 place, 4 to the power 1 place, and 4 to the power 0 place.
Yeah.
And so the way that I calculated that power value was to take the length of the array and then subtract it by the index plus 1, because the index is always is 0 indexed.
Yes.
So I need to add 1 to give it.
And I have to use an example to work that out when I'm trying to figure out what do I need to put there. I know that it's related to the index, and I know that if I have to go backwards, that it's going to be related to the length in the index.
Yeah.
But working out if it's plus 1 or one or minus 1, I have to actually throw in an example to see. Yeah, and then I work it out. So if the length is
Paper first.
exactly, yeah, and that's a totally legitimate way to do things because unless you have one of those minds that just like picks up on that without needing an example.
Do you think it's legitimate to just write the code out and then try it 3 times with -1, 0, and +1?
Sure.
Okay.
Yeah, that's totally fine too.
That's my normal.
Yeah. That's totally fine too. Nothing wrong with that. Nothing wrong with that. So for this one, I would look at that 1, 3, 2, 3 example and say, okay, the length is 4. I'm going to start with an index of 0. 4 minus 0 is 4, but I don't want to raise 4 to the power 4. I want to raise 4 to the power 3, so I need to subtract a 1 there. And I would just do that to work it out. And say, okay, well, I need length minus index plus 1. And then I would convince myself that that works for, for each one. Yeah. And then I'd feel like, okay, yeah, that's what I need to use.
I also ran into the same problem as Matt, and I was talking to Janelle and could not figure out why it didn't work, because I was like, it certainly should work, but just have the arrow instead of double.
Yeah, instead of the double asterisk to raise to the power, we assumed that it would just be the caret, because why wouldn't it be, right? I mean, that would make sense. But apparently no, not in Ruby land. That's not how it is. So that symbol is used for something else in maths. Something weird. We should look up what it is because I don't know what it is.
Is that what it is in Java? Because it's the 2 asterisks in JavaScript.
Yeah. I can't remember. It's been too long since I've done Java. Yeah.
Does anyone care about the digits method? Because there's a reason why it doesn't.
Yes. Tell us.
So digit doesn't actually do what chars does.
Right.
It's just a happy byproduct. Digits is actually doing what we're doing and is doing a conversion for us, but it's default by 10. So we can pass an optional parameter of the base, and it splits it up into an array of those decimal base positions or values. So
it's showing you like the 0 place and the 1 place and the 2 place. Right.
So if you did digits
like 4,
it'll tell you how many 1s, and then how many 4s, and then how many 8s.
8s.
And 16s.
Right. How many? Yeah, 4s,
So
16s.
it's essentially what we're doing, but smarter.
Right.
So that's why it doesn't reverse.
So you could say digits with 4 and then reverse it, and you would have the number in base 4.
Oh, yeah.
Yeah?
You would.
Or no, it assumes that, does it assume that the number that it's called against is base 4?
You have to pass
I think it takes only base 10 and it converts that to
Whatever
your
you pass
chosen
as an
power.
argument?
Yeah,
Okay.
or your chosen base.
Right. So if we did like 100.
Because it's doing place value notation, it's starting from right and moving left.
Yes.
Because I thought it did a split as well.
We did 100.
It doesn't.
digits.
Pass up the 1, 0.
Right.
So yeah, by default, it's base 10 when we do digits, because we all think it just does the same thing as chars.
Right.
But with that optional parameter of your base, it
Right.
actually does something different.
64.
So you reverse that, I'll actually
32.
No, I'm not
It still would make sense to do it, yet, like, in my mind, it would still make sense to place, like, for it to reverse the array itself.
Yeah.
That makes it more readable.
Yeah, because 100 in base 4 would be 1210.
Yeah, exactly.
If you reverse it, then it just makes the algorithm more complex.
I think the
So,
bloke who
yeah, it
did
does.
this,
But it does, yeah.
I think
if
the
you
bloke
want
who
that way
made the
around, then
method,
it's more
like you know
efficient.
how on the board you did your 1 by your power to the power of blah, you did
Yeah.
it from left to right.
Yeah.
I think the bloke who did this method does it right from left, like he starts
Right.
with his 1s and then his 10s and his 100s.
Right. Right.
Pushes it to the array.
Because that makes sense to me because I do it that way.
Right.
It hurt my brain
When I did it the other
doing
way.
The other way. I got
Right,
confused
right.
because
Okay. Okay, that's good to
I
know.
think that's why it's the way it is.
Right. Right. So when we're writing it in expanded notation, it makes more sense to you to start from the ones place.
Yes. That
Yes.
is for me anyway. So.
The
Yes.
algorithm would have to start from the ones place as well, right?
Yeah.
So that it can just chop off 1 digit at a time.
Yeah. Yep. Cool. Cool. So it's good to know that we can use this, though, if we wanted to do a quick conversion, you know, from a number in base 10 to another base. Does it work if we say something bigger than 10?
Yes. It does.
Yeah, let's do one with a letter in it, like...
255.
255.
Ah, but it gives it to us like this.
Decimal.
Yeah,
Cool.
yeah.
So it probably doesn't like letters.
Yeah, it doesn't. Yeah. Yeah, well, you can see that it returns arrays with numbers in them and not characters.
Does
Yeah.
it still work?
That'd be easy enough to do a conversion on that. Like, that's pretty good.
Yeah, it wouldn't be too hard. Sweet.
So if you wanted to, Matt, you could just do one big array
Yeah.
and just do that instead. Just do
It's
that.
digits. No, it's good to
Only in
understand
one
the
direction,
process. Yeah, only in one direction. It's only
Yeah,
one
that's
direction.
right.
It's good to understand the process. Though if you understand the process, then you'll be fine for the test. But also, you have an understanding of what bases are about. It's not anything too magic. It's definitely a methodical set of steps that you apply to convert from one to the other. Good stuff. Right.